This is chapter 6, number 69, reassessment number 8, potential energy. So part A of the problem, sorry, there is a picture that goes with this problem. You could look it up in the book, number 69. The part A of this problem asks us what is the block speed when it's at its height of 0.25 above the base of the slide. So so we can use W equals delta E. Work would be 0. If we rearrange this, we'll get Kf minus Ki plus Uf minus Ui. Or if we rearrange it even more, we get that. We know K of I would be equal to 0. We want to solve for v squared, or sorry, for the velocity v. We know K, the equation for K would be 1/2 mv squared, and the equation for the gravity potential energy would be mgy. So we would get mgy on this side, and 1/2 mv squared. We could plug in for everything. This would be 0.25. This would be its starting position on the far left. We'll solve for v, and we'll get 2.21 meters per second. That would be the speed of the block once it reaches the height of 0.25. So part B is asking how far the spring is compressed once it reaches all the way to the bottom. So we know the potential energy of the spring should be equal to the potential energy due to gravity. So Ug would be equal to Us, or mgh would be equal to 1/2 Ks squared, where S is how much the spring is compressed. So we know the height would be 0.5. We know h, which would be 0.5. We know the mass would be 2 kilograms, and we know it gives us the K value, K constant, of 450 newtons per meter. So we plug everything in to solve for S, and we get S equals 0.21 meters. That's how far the spring can compress once that block slides all the way down. So I don't have part C on the paper, but it asks for how high does the block go after the spring pushes it back. Since we know the slope is frictionless, the energy, it's not losing energy once it goes back up the ramp. It's not losing energy once it's going down the ramp. Therefore, once it goes all the way down, gets pushed back up, there's nothing slowing it down. It would go all the way back to its original position, and the process would start over again, over and over again. That's because there is no friction slowing it down. I mean, if there was air resistance, that is not friction, but I mean, air resistance would slow it down, but it didn't say anything about air resistance, so it would go all the way back to its original position. All right, thank you. That's number 69.